Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In the second video of vector product, we will discuss example 1 until example 3. So in example 1, so if vector A to I minus j minus k and vector B I plus j minus k show that the cross product of AB equals to negative of cross product BA. And then B 3A cross product with 2B equals to 6 times cross product of AB. So let's see the solution. Right, so the first one, so here's the given vector A and vector B. And we find straight away we find out the negative of vector B. So the ij will be negative and k will be positive. And then next, we will calculate the cross product of AB. So remember the cross product, it is similar like determinant 3 times 3. So the first row will be ijk, the second row the vector A, and the third row will be the vector B. And then we expand similar like determinant. So as you can see, it is similar with the concept of determinant. To find determinant, and later on we'll find out that the cross product of AB would be 2i plus j plus 3k. On the other hand, the cross product of negative B and with A. So notice that we start with negative B. So here is negative B, negative I, negative j plus k. So negative, negative 1, and then 1. And then vector A 2, negative 1, negative 1. And then we expand, as I said, it is similar with finding the determinant. Okay, finding the determinant. And then the answer would be 2i plus j plus 3k. And when we compare with A cross B, it is similar, right? So we can equate with A cross B. Or we can write down the conclusion below like this. So therefore, we can prove that the cross product of AB equals to negative of cross product BA. Okay? Right. Actually, there is another way to find out. So, there is, first we find out the cross product BA. So, we switch place between B and A. So, the second row will be vector B and the third row will be vector A. And then we'll find out, then we get negative 2i minus j minus 3k. So if we factor out the negative, so inside here all will be positive. And when we compare with the A cross B, it is actually A cross B, right? So we can conclude that also that A cross B is actually a negative of B cross A. Okay, this is the second method. But it's up to you which method you want to use. Personally, I suggest we use the first method. Okay. Right, next for question B. So in question B, 3 times vector A cross product with 2 times vector B. So we expand first. So this is after expand, 3 times vector A. So we come to C as negative 3 and negative 3 respectively. And also 2 times vector B, so it will be 2, 2 and negative 2. So after we multiply with coefficient 3 and 2 respectively, and then we do the cross product. So we do the cross product. So as usual, the first row will be ijk, the second row will be vector 3a, and the third row will be vector 2b. And then we expand like a final determinant, and then we get the answer 12i plus 6j plus 18k. So notice that it is a multiplication of 6, right? So we can factor out 6 So would be 2i plus j plus 3k. So this 2i plus j plus 3k is actually dA cross B. And then with that we can show that the cross product of 3a and 2b is actually 3 times the cross product of AB. Okay. Right. So now we move to the example 2. So in example 2, given vector A, I plus 2j plus 3k and vector B, negative I plus 3j minus k. So first find out the cross product of AB and then prove that A cross B is a vector which is perpendicular to the vector A. So let's see the solution. So the first one, find out the cross product of AB. So as usual, the first row will be ijk, the second row vector A, and the third row will be vector B. Then we expand, as I said, like find out the determinant. And then the answer will be negative 11i minus 2j plus 5k. Right. So next, the question asks us to show that the cross product of AB is actually perpendicular with A. So remember previously when we discussed about scalar product, or also we call it as a dot product, one of the properties is if the two vectors are perpendicular, then the dot product between the two vectors would be 0. So we use these properties. There is the cross product of AB. If we dot product with vector A, if it is perpendicular, so the dot product should be 0. So let's find out. Is it 0 or not? So substitute the cross product of vector AB. So negative 11, negative 2 and 5. And then 1, 2, 3 from vector A. Remember how we calculate the dot product? So we multiply according to the component, right? I with I, J with J, and K with K. So after we calculate, we find out that it is, yeah, it should be 0. So if that's the case, proven it is 0, then we can conclude that the A cross B is perpendicular to vector A. Right, next for example 3. Find all vectors of length 11 unit which are perpendicular to both vector A and vector B. So remember, perpendicular to both vector means that we have to find out the cross product first, okay? Because the cross product itself should be perpendicular to both these vectors, okay? So first we find out the cross product of AB. So the cross product of AB, so no need to explain anymore. You should know how we use the cross product. So just give out the answer. So the answer will be negative 6i plus 2j minus 2k. Okay, so from here, remember the first subtopic we already discussed about this kind of question, right? The vector of given certain length. Remember? What you need to do? Yeah, you have to find out its unit vector first, right? So after we find out the cross product here, then we need to find out its magnitude. So the magnitude of the cross product will be, so remember the formula how to find the magnitude. So the magnitude will be cert 44. Then the unit vector, so remember the unit vector, so we put cap above the cross product. So 1 over determinant, oh sorry, this time is not determinant, magnitude, okay? So 1 over magnitude, and then times the cross product, okay? So just leave it just like this because it is not final answer yet. Later on we have to multiply with 11, right? Okay, so we move to the next slide. How we multiply with 11? Okay, the question asks all vectors length 11. Does it mean same direction or just in general? So if the question just mentioned the vector length set11 in general, it means that we have to consider two possibilities. The first one, if the vectors is in the same direction. So if it's the case, so we have to multiply with set11 with its unit vector. So set11 over set44 we can simplify, and actually it will be 1 over 2, okay? Because set 1 over 4 is actually 1 over 2, okay? And then we can simplify or divide each component with 2, and then we should get the vector. So I name it as a V1, the vector that having a set11 unit. So I number it as a V1 because we have two possible answer, right? So the first one I name it as a V1. So V1 is actually equals to negative 3i plus j minus k. And then what should be the second possibility? Apart from same direction, the other one should be, yes, the opposite direction. So for the opposite direction, we have to put the negative sign in front of the set11, okay? So in front of set11, we'll put negative sign, and then the rest will be same. So the second step will be negative 1 over 2, okay? So the answer should be more or less similar to V1, except the sign will change, right? Positive will become negative, and negative will become positive. So for V2, the answer is 3i minus j plus k. So here, these two possibilities of vector having set11 unit. Okay? Right, so I think that's all for this first part of the example. So don't forget, we still have 3 examples, that is example 4 until example 6 in the next video. So stay tuned for the next video. Until then, thank you very much. Bye-bye.